Good morning. Sorry about the weather again today, but thankfully we have the capability to have me record some of the solutions that I was going to go over in class today. So I'm going to start with something that deals with the gasoline gauge in a van. Suppose the gas gauge initially read that it was 1/8 full. Then, when 15 gallons were added to the tank, the gauge read 3/4 full. How many more gallons are needed to fill the tank? So I like to draw a picture for this one. Imagine the entire tank. If we need to see visually what 1/8 looks like, I break up the tank into 8 equal chunks and I fill them, 1 full. So now this tank is 1/8 full. Then we add 15 gallons. And the gauge then reads 3/4 full. So I'm going to draw the same picture. And in a different color, I'm going to add enough so that it's 3/4 full. 3/4 full, if there are 8 total boxes that would hold the gas, as it were, we would need that 3/4 would be 6/8. So we have to fill 1, 2, 3, 4, 5 more. So 5/8 of the tank is equivalent to 15 gallons. We need to know how much goes up in these last 2 boxes. So really what we have to figure out is when we added the 15 gallons, how many gallons went into each of these 5. So it's a nice division problem. 15 gallons in 5 segments, 5 boxes. That means there are 3 gallons per each box. And so since we had to fill 1, 2 boxes, that means 6 gallons would need to be put into the tank to fill it. If you took a look at the MyMathLab problems, there were some fun ones in there, including this fun riddle. Catwoman is Batman's nemesis, and she asks Batman this riddle, or actually answers this riddle. How many cats do you have? I have 5/6 of my cats plus 7. So what we're going to do is say, okay, she has C cats. So the answer to Batman's question, how many cats does Catwoman have? Well, that answer is C cats. So we ultimately need to find what C is. Instead of saying that she has 3 cats or 5 cats, she says 5/6 of my cats plus 7. So the number of cats she has is equivalent to 5/6 the number of cats plus 7. And we have a nice linear equation. We haven't really talked about yet how to solve an equation like this. Many students in the past have started learning how to do these back in middle school and 7th, 8th grade, somewhere in there. So what we will do is we will rewrite the C on the left as 6/6 C, and the right will still be 5/6 C plus 7. We'll subtract 5/6 C from both sides and use some of the skills we had with the subtraction and addition of rational numbers from Unit 1. 6/6 minus 5/6 is 1/6. So we have 1/6 the number of cats equals 7. And finally, we multiply both sides by 6 to get that C is 42 cats. So Catwoman has 42 cats because 5/6 of her cats plus 7 is equivalent to 42. Here is a distance problem. While traveling to his grandmother's for Christmas, George fell asleep halfway through the journey. When he woke up, he still had to travel half the distance that he had traveled while sleeping. For what part of the entire journey had he been asleep? I like to draw a picture. I like reading left to right. So I'm going to say George's house is over here on the left, and Grandma, her house is on the right. We have the whole journey that is, we don't know how long yet. At the halfway point right here, actually I'll write the half above, George fell asleep. When he woke up, somewhere in the middle, I don't know exactly where yet, so I'm just going to say he woke up here. So he had this portion on the left where he was asleep, and this portion on the right where he will still be awake after waking up from his nap. So when he woke up, at this point right here, he still had to travel half the distance that he traveled while sleeping. So this awake time is half of the asleep time here. That means that the asleep to awake ratio is 2 to 1. So if we think of chunks of time, that is 3 chunks of total time. I can't spell today. So in other words, suppose the whole trip was an hour and he fell asleep half an hour in, and then in the remaining half he was asleep for 2/3 of that and awake for 1/3 of that. We would say that the sleep time was 20 minutes and the awake time would be 10 minutes. Those aren't the actual numbers here, but that gives us the ratio. So the actual answer we're looking for, what part of the entire journey had he been asleep, we're actually looking for a fraction. So he was asleep for 2/3 of the second half. 2/3 of half of the journey, which means we can multiply 2/3 times 1/2 to get 2/6 or 1/3 of the whole journey. That's how much he was asleep. So he was awake for the first half, and in the second half he was asleep for 2/3 of that half. So 2/3 of that half means 1/3 of the entire whole. So he was asleep for 1/3 of the whole journey. However long it took, he was asleep for 1/3 of it. Here's another one that's similar to something you may have seen in my math lab. A frog is at the bottom of a 20-foot well. Each day it crawls up 4 feet, but each night it slips back 3 feet. How many days will after how many days will the frog reach the top of the well? I like to draw a great big picture here. Imagine a skinny well in reality, but I'm going to generate some data here. So we know that the height of the well is 20 feet. Let me write that 20 more clearly. On day 1, we go up 4. I'll use up 4, and then we go down 3 for a net gain of 1 foot. The frog will go up 4 feet, then down 3 during the night. So at the start of day 2, the frog is 1 foot up. It will go up 4, down 3. So the initial height of 1 foot, we get a second foot on day 2. Then on day 3, we start 2 feet up, we go up 4, down 3, gaining a third foot. We continue this along. So I'm going to use ellipses here. Let's go to, say, day 15. At day 15, we start 14 feet up because that's where it ended the previous day. If we look at the pattern, at the end of day and night 1, the frog is 1 foot up. End of day and night 2, the frog is 2 feet up. End of day and night 3, the frog is 3 feet up. So at the end of day 14, the frog is 14 feet up, and that's where it starts on day 15. So on day 15, it gains 4 feet to get to 18 and falls 3 to get to 15. So day 16, it starts at 15 feet, goes up 4 to 19, back down 3 to 16 feet. And day 17, the frog starts at 16 feet and goes up 4. 16 plus 4 is 20. On day 17, the frog has climbed 20 feet total, 1 foot gained each day for 16 days, and on day 17, it started at 16 feet up, climbed 4 feet, and before it had a chance to slip back at night 3 feet, it crawled out 17 days. All right, that's a good plethora of examples from MyMathLab and out of the book. Go ahead and finish the MyMathLab for 1.3 for Friday. Have a great day.